Good morning, children. Today we are going to see Galiliean transformation equations. Already in the first class I told you in the unit relativity that there are three concepts. One is length contraction, second one is time dilation, and third one is mass contraction. So that is known as length contraction, time dilation, and mass variation. We know that length contraction can be written as L is equal to L naught into root of 1 minus V square by C square. This is known as length contraction. Time dilation T is equal to T naught divided by root of 1 minus V square by C square, and mass variation M is equal to M naught divided by root of 1 minus V square by C square. These are the three basic concepts that gave the theory of relativity. Relativity was a very good chapter to solve the problem of length contraction, time dilation, and mass variation. Based on that, we have got two types of transformation equations. One is known as Galiliean transformation equations and another one is known as Lorentz transformation equations. Today we are going to see Galiliean transformation equations. Before that, you should know that relativity deals with three-dimensional aspects. That is, we are going to consider a particle in X plane, Y plane, and Z plane. So we are going to consider two frame of references. One is an accelerated frame, another is an unaccelerated frame. Unaccelerated frame means it will stand still. Accelerated frame means it is move forward. Now we are going to consider two systems. One system is S dash and another system is S and S dash. We are going to consider two systems. One is S and one is S dash. We are going to consider two observers. Let O be the observer in the system S and O dash be the observer in the system S dash. First system is X, Y, Z with observer O. The second system S dash is X dash, Y dash, Z dash with an observer O dash. Now I am going to consider a particle P in the system S dash at a distance X from the observer. So I mark X dash. Now another observer from the S system will see the particle at a distance X. We know that velocity is equal to distance by time. Therefore we can write distance is equal to velocity into time. So when we are considering two systems S and S dash, before starting the two observers and O dash will be coinciding. This is the first point. Second point, when the frame S dash is moving relative to S, there will be variation in distance. So it is moving with a distance X dash. Now there will be a change in velocity and change in distance. Therefore, the time taken by the second frame to travel that distance is nothing but t is equal to Vt. Therefore, the new distance covered by the second frame of reference will be x dash is equal to x minus Vt. I told you in coordinates there are two types of coordinates. Linear coordinates and we can write it as polar coordinates. Linear coordinates are nothing but you will express an equation in terms of x, y, z and t. Polar coordinates means expressing an equation in terms of r, theta and pi. So here we are using only x, y, z. Therefore, we must see what is the movement of the particle in X plane, Y plane, Z plane in time. So we are taking four factors. Here the movement of the particle will always be only in the X plane. Therefore, there will be no change in Y plane and Z plane. So the equation will be respect to only X plane. So one system, another system is s dash. We know velocity is equal to distance by time. Distance is equal to velocity into time. Therefore, we can express t is equal to vt. That is the time taken by the second system to move from another system. Suppose there is one observer, another observer. When the two observers are observing a particle, there will be a difference between the two observers in terms of length, in terms of mass, in terms of time, because one particle is moving relative to one another. That is what I told you. When the two observers are viewing the same particle, there will be a difference in length. That means length contraction, difference in time, time dilation, different in mass, mass variation, because the particles are moving with the velocity of light. So Galiliean took this concept and has given the Galiliean transformation equations as x dash is equal to x minus vt, equation number 1, y dash is equal to y, equation number 2, z dash minus is equal to z, and t dash equal to 2. These four equations are known as Galiliean transformation equations. These four equations are known as Galiliean transformation equations. Also, you can express the same aspect in terms of Galiliean inverse transformation equations. In Galiliean transformation equations, I told you when the particle is moving from S to S dash, these are the equations written. X dash is equal to x minus vt, y dash equal to y, z dash equal to z, t dash equal to t. If suppose the particle is moving in the reverse direction from the frame S dash to S, or from the system S dash to S, then you can express the inverse transformation Galiliean equations as x equal to x dash plus vt, y is equal to y dash, z is equal to z dash, t is equal to t dash. So that you have to remember. So Galiliean transformation equations are x dash equal to x minus vt, y equal to y dash equal to y, z dash equal to z, t dash equal to t. But when the frame of reference or the observer is moving in the opposite direction from S dash to S, we get another type of equations, and that type of equations are known as inverse transformation equations, and that is given as x equal to x dash plus vt, y is equal to y dash, z is equal to z dash, and t is equal to t dash. That is the first point was there, which Galiliean form. Second one is telling the transformation of velocities from one system to another system is obtained by taking time derivatives. Because when a particle is moving from one frame of reference to another frame of reference, definitely there will be a change in time. So all other derivatives are depending on time, and this movement is taken in x-plane. So there is difference in the derivatives, and that difference in derivatives can be written as, if there is change in the x-plane, then you can write dx by dt. In the system S dash, this can be expressed as dx by dt dash. If there is change in initial velocity, you can write du by dt is equal to du by dt dash. If there is change in final velocity, we can write this as dv by dt is equal to dv by dt dash. So these are all the time derivatives. Suppose the derivative of the initial velocity, final velocity, and the distance are dependent on time, we call them as time derivatives. That is dx by dt is equal to dx by dt dash, or du by dt is equal to du by dt dash, dv by dt is equal to dv by dt dash. So these are all the time derivatives of. So there were some defects in the Galiliean transformation equations. The defects were to be removed, and therefore for removing the defects, we are going to study another transformation equations. They are known as Lorentz transformation equations. They are known as what? Lorentz. So Galiliean transformation equations had some defects. That defects had to be removed. The removal of the defect by another scientist, Lorentz, was taken, and that is known as Lorentz transformation equations. So after Galiliean transformation equations, there was a scientist by name Michelson and Morley. Two scientists, Michelson and Morley, performed an experiment to see whether they are able to satisfy Galiliean transformation equations, and with the help of Galiliean transformation equations, they were trying to find the velocity of light. So apart from three mediums, solid medium, liquid medium, gaseous medium, they said that another medium is existing on the earth, and that medium is known as ether medium. The fourth medium is known as ether medium. So they told that we can now determine the velocity of light with the help of the ether medium, because the property of ether medium is to drag the particle, and they were able to trying to find the velocity of light. When they found the velocity of light, it was not equal to 3 into 10 power 8 meter per second. So Michelson-Morley experiment was a failure. So Michelson and Morley performed an experiment to find the velocity of light. They said that they considered two systems, time all. But they told that there was another medium called ether medium. The ether medium had the property of dragging the particle from the one system to another system. But that was a failure, because they were not able to satisfy the velocity of light. The universal velocity of light is 3 into 10 power 8 meter per second. So Michelson-Morley experiment was a failure. So in the syllabus you are having negative results of Michelson-Morley experiment. Negative results of Michelson-Morley experiment. So that negative results are three things. The negative results are three things. One, you have to express what are the negative results. So the first negative result is that the earth dragged along with it the ether in the immediate neighbor. So in the next is when the particle is moving from one place to another, the next medium will be ether medium, and it is dragging. Thus there was no relative motion. What is this relativity means? There must be relative motion in length, time, mass. So that only we are saying relative. So when it is dragging, it is getting dragged, but there was no relative motion. So Lorentz and Fitzgerald put forth this suggestion. So they took this suggestion, and there was contraction of bodies along the direction. So now we are getting the idea of length contraction, motion through the ether. There was no time difference, so they were not able to calculate time dilation. So in the two parts of the Michelson, this contraction hypothesis easily explains why it gave a negative result. There was length contraction, no time dilation. So Michelson-Morley experiment gave negative results. So that was going to be proved by the next man, Lorentz, and we are going to derive the equations known as Lorentz transformation equation. The explanation of negative result was given by Einstein. You know the Einstein equation, E is equal to mc square. With the help of velocity, it can be converted to energy, and energy can be converted into mass. He concluded the velocity of light in space is a universal constant. That is, throughout the world, the velocity of light will not change, and it will be 3 into 10 power 8. So the value founded by Michelson-Morley was less than the value of 3 10 power 8. So it was a failure. It is a universal constant which is called the principle of constancy of speed of light. The velocity of light found by Einstein is said to be universal, and it is called the principle of constancy of the speed of light. So Galiliean transformation equations are a failure. Now in the next class we will be deriving Lorentz transformation equations. So we will be deriving Lorentz transformation equations in the next class. See you. Thank you.